Welcome to iTTV for Form 2 Science, where we continue our journey through the world of our senses. Today's lesson, the limitations of sight. We've already started looking at sight. We know that the sense organ that detects light stimulus is the eye. We know that on the retina at the back of the eye is where our photoreceptors are. We know that the photoreceptors detect the light stimulus and send messages to our brain. The problem that we have is some things cannot be detected by our eye. Also, sometimes too much information is sent to our brain and our brain can't understand the information correctly. These are the two aspects that we want to look at today. Firstly, not enough light, which means that we cannot detect the stimulus. And secondly, too much information, meaning that the brain misunderstands the messages. We cannot see tiny objects like bacteria and virus. Now, the reason that we can't see these objects is because they, being so tiny, only reflect a certain amount of light. Our eyesight depends on reflected light entering into it. When you see a car, the car, which is quite large, is reflecting a large amount of light into our eye. So our eye can detect the stimulus and interpret it as a car. But with a bacteria or a virus, the amount of light that reflects into our eye is very, very tiny, which means that the retina and the photoreceptors are not stimulated enough. Therefore, if they're not stimulated enough, we can't see those objects clearly. We cannot see very far away objects. Now, this is really to do with, say, looking at planets or looking at stars or looking at something that is very, very far away from you. With the case of the planets and the stars, because they are so far away, the amount of light traveling from them into our eye, once again, is not enough to create a very good impression in our brain. Now, with very far away objects, example, you're sitting on the beach and in the far horizon, you may see what appears to be a boat. Once again, the amount of light traveling into our eye is not enough to make a clear picture of what the object is. So understand the limitations that we have. We can't see tiny objects because there's not enough light coming into our eye. And with very far away objects, the amount of light entering our eye is not enough to create a clear image of what is happening or what is there. The blind spot. Area where the optic nerve, area where the optic nerve leaves the eye. No photoreceptors present. Now, with the blind spot, the problem we have is light falling on the blind spot. When the light falls on the blind spot, there are no photoreceptors, as we've said, which means that there is nothing there to actually be stimulated or to detect that there is light there. Now, the blind spot actually is a bit of a problem. It occurs mainly when we are driving. When we drive, sometimes objects appear or are sitting in our blind spot. When they appear or sit in our blind spot, we can't actually see them. And this is a problem when we are changing lanes in a car. What we should see, that there's a car sitting right next to us, we can't see. So we swerve and suddenly we hear this bap horn because there's actually a car and it's sitting right in our blind spot. Now, this is easily overcome. As you will learn when you go for your driving lessons, you're supposed to always turn your head to your right to have a look before you change lanes. And the reason for this is to overcome the problem of the blind spot. Now, what we're going to do is we're going to do a simple experiment where we're going to try to detect the blind spot. So what I need all of you to do is to sit quite close to your television screen, roughly about 1 foot to 1.5 feet away from the screen itself. Now, on your screen, you can see a cross and a dot. What you need to do is place your face so that your nose is between the cross and the dot. Are you all sitting there already? Very good. Now we'll move on to the next step. Cover your left eye and stare at the cross with your right eye. So cover your left eye with your hand and using your right eye, stare at the cross. Are you doing this? Okay, now we're going to move on to the last step. Please remember to keep that left eye closed. Now, slowly move towards the computer or the TV screen. Do it slowly. Keep moving until suddenly the dot should disappear. Keep your right eye always on the cross. Move your head slowly towards the screen and the dot should disappear. Now, when the dot disappears, which is roughly about 10 to 14 inches from the screen, what is occurring here is the light from the dot is actually falling on your blind spot. So instead of you seeing the dot, suddenly the dot disappears. And it disappears because the light from the dot is falling on the blind spot and it cannot be detected. Okay, so remember, if you're sitting in front of the screen, close your left eye, look at the cross with your right eye. Once you're comfortable, move your head slowly towards the screen, keeping your eye, your right eye, looking at the cross. Move slowly, and then you should notice suddenly the spot disappears. Why? Because like we said, the light from the spot is falling on your blind spot and you can't see it. At somewhere around 10 to 14 inches from the screen, the black circle will disappear and the area where the black circle was will now be all white. This is your blind spot. Now let's go on and have a look at a few other limitations of sight. If you move closer to the screen or farther away, the circle will reappear. At just the right distance, the circle will disappear. Now if you move forward or backwards, it reappears because the light is not longer falling onto the blind spot. It's falling onto the retina where there are photoreceptors that will detect the reflection coming off the black spot. Why do optical illusions occur? Okay, on your screen now, you'll notice that there is a set of circles. Now, if you look at those circles closely, what do you notice? Just take your time, look at the circles closely. What do you notice? Do you notice that the circles are spinning around? Okay, so circles are spinning around. Now, what I need you to understand is the circles are not spinning around. The circles are actually on a piece of paper, which means they cannot spin around. They appear to be spinning around because of a phenomena that we call optical illusion. Now, why does an optical illusion occur? The brain is sent too much information and interprets the nerve impulses wrongly. And when there's too much information and the brain interprets this wrongly, we have the phenomena of optical illusion. This is a very famous optical illusion because, as I've said, the circles are certainly not moving. But even though they are not moving, the brain information is just too much for the brain. So the brain seems to misunderstand it, and it gives us this feeling that the circles are actually spinning. It always gets me because every time I look at it, Even though I know that they're not spinning, they still appear to spin. Another very famous optical illusion is one that just requires a few lines. So, I'm going to do this one up here, okay? I'm going to draw two lines that are of the same length. Now, you're going to see me do this. So I'm going to draw one line over here, and then I'm going to draw another line over here. Now, you should clearly be able to see that the two lines are exactly the same length. Now, I'm just going to do a little tweaking, which means to say I'm going to send your brain too much information. On the first line, I'm going to draw the arrow shape like this. On the second line, I'm going to draw the arrow shape differently. Now, just by putting those additional lines on the diagram, suddenly it appears as if this line is longer than this line. But it's not, isn't it? You saw me draw the lines. You saw that the two lines were exactly the same length. But just by putting these extra bits on it, it suddenly appears as if the line on the right-hand side is longer than the line on the left-hand side. This is an example of optical illusion. Too much information is being sent to the brain, and the brain misunderstands it. It interprets the information wrongly, and we have these phenomena occurring. The circles appear to be moving. They are not moving. Remember what I said just now. The circles appear to be moving, but they're not. So remember, it's just an optical illusion. When we use both eyes to look at an object, it is called stereoscopic vision. Now, when we look at things, we use our eyes. And we have two types of vision based on our eyes. We have what is called stereoscopic vision and monocular vision. Stereoscopic vision means we use both our eyes to see. I'm not using just one eye, I'm actually using both of them at the same time. Both eyes are in the front of the face. Both eyes are in the front of the face. You cannot have stereoscopic vision if your eyes are to the side of your face. That is for monocular vision, as we'll look at later. So both eyes are in the front of the face. The field of stereoscopic vision is the area where the fields of vision of both eyes overlap. So with one eye, you're looking like this, and the other eye, you are looking like this. Where the two visions overlap, that is our area of stereoscopic vision. Stereoscopic vision enables us to estimate the position and distance of an object more accurately. So, what is the value of stereoscopic vision? Well, the value of it is, as it says, it's easier for us to detect distances and the position of objects by using our stereoscopic vision. It allows us to see in 3 dimensions. It allows us to be able to say to someone, oh, it looks like it's 10 meters away, or it's sitting at the top of the table. All of these statements that we make are because we have stereoscopic vision and we are able to gauge or judge distances and positions quite accurately. Stereoscopic vision enables predators to detect their prey easily. Because of the stereoscopic vision, birds of prey like the hawk or the eagle can actually spot their prey close to 1 to 2 kilometers away. That is how good their eyesight is in terms of judging distance and position. That's why a hawk or an eagle can swoop down from the sky having seen a prey miles away from it, and then pick up that rabbit straight up into the air and then yum, 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 eat it. So understand, all preys, tigers, leopards, bears, we all have stereoscopic vision because it helps us gauge distances. Now let's have a look at the other side of stereoscopic vision, which is monocular vision. What you can see when you use only one eye is called monocular vision. Eyes are at the side of the head. Now, when your eyes are at the side of the head, each field of vision is totally separate. The two fields do not overlap with each other. You can't really judge distances, but what you do have is a much larger field of vision because you can see almost 360 degrees around you. The benefit of this is that you can see if anything is coming towards you. So it's very good for preys such as the rabbit or the deer to have monocular vision because they can see the hawk or the tiger or the leopard coming towards them. With animals that have monocular vision, their eyes are at the side of their head. This means that their fields of vision are at the side of their head. The two fields don't overlap each other. They don't overlap, which means that it's not easy for these animals to gauge distances. But it's very good for them in that they can almost see 360 degrees around themselves. What you can see when you use only one eye is a wide field of vision, roughly 360 degrees. And how is this important or useful to animals with monocular vision? Monocular vision enables animals to detect predators from any angle, which is to say, if the tiger is coming up behind you, or if the lion is coming down your left-hand side, all of which are behind you and you're not supposed to see them, well, you are able to see them because of this effect of seeing 360 degrees roughly. That is a product of having monocular vision. Now, the microscope. A microscope is used to help us see very tiny objects such as bacteria and cells. The microscope is a device that helps us overcome the limitation of sight. We said at the beginning of the lesson that one of the problems we had with our sight was we couldn't see tiny or far away objects. So we human beings have invented a lot of devices that help us overcome this limitation of sight. One of them is the microscope, which allows us to see tiny bacteria or protozoa on slides, and we can magnify it and then be able to see them in a bit more detail. Devices to overcome limitations of sight. Optical instruments are necessary to overcome the limitations of the eye. Now remember, at the beginning of the lesson we said that the main limitations of the eye were really that we couldn't see tiny objects or we couldn't see far away objects clearly. So we human beings have invented a whole array of devices that allow us to overcome these limitations. Magnifying glass. A magnifying glass has limited power but helps us to examine tiny objects. Here we're using a magnifying glass to allow us to see tiny objects. Now we can see the object, it's just that we can't see it clearly enough. Not like cells or bacteria where we need the microscope because we can't see them at all. So here we can see the object, but it's just not clear. By using the microscope, we make it clearer because we are magnifying the image so that we can see the detail inside it. Telescope. A telescope is used to help us see distant objects such as the stars. So the telescope allows us to see these stars or planets or even our moon. Here, the problem was we couldn't see enough detail. It wasn't clear. What the telescope allows us to do is it allows us to see these distant objects much more clearly. Periscope, to see over obstacles. Now, if you're standing behind a crowd of people, say you've gone to see a parade or something of that nature, or even a golf tournament or equestrian event, and you're, say, 5 people behind, which means you can't really see. And if you're like me, who is slightly a bit shorter than normal, also it means you can't see. Now, to overcome this problem, we use a periscope. By putting the periscope in front of me, I'm able to see over the people in front of me or the fence in front of me, and it overcomes the problem of my eyesight limitation. Now that we've had a look at the limitation of sight, we understand that we can't see tiny or far away objects. Also, if we get too much information coming into our brain, we misinterpret it. We've also seen about the types of vision that animals have, which is stereoscopic vision, which enables us to judge distances, or monocular vision, which gives us a wide field of vision. Let's try some questions on what we've learned today. Question 1. Where is the blind spot? So if you remember just now, we said that the blind spot was at a particular location on the eye. Where was it? Let's have a look at the answer. On the optic nerve. The blind spot is on the optic nerve. Let's try another question. Why do optical illusions occur? Remember those optical illusions like the lines on the board? Why do they occur? There's something that causes it to occur. Let's have a look at the answer. Too much information for the brain to interpret. Too much information for the brain to interpret, so it interprets incorrectly and we have optical illusions. Let's try one last question. What is the benefit of stereoscopic vision? Now, you and I have both got stereoscopic vision. Our eyes are in the front of our face. How does this help us? Let's have a look at the answer. Allows us to gauge distance accurately. So the benefit of stereoscopic vision is that it allows us to gauge distances correctly. Well, that's all the time we have for today's lesson. Thank you for watching iTTV.